Welcome to video 5. Our next step in making the squares for the glass sponge pattern will be to divide up the bottom curves, essentially just getting points that are equal distance apart along our bottom curves. Let's jump right in where we left off. Now that we have the joined bottom curve, let's put this in a component. Just get a curve component and call this bottom curve. And we can hide this. And let's group all of this so we know what this little section is doing. Control G. Let's call it get bottom curve. And let's move all of this down a little bit. So this next step is going to be very simple for the flat surface and for the circle, but a little more complicated for these other three, and you'll see why in a minute. All we're going to do is divide the bottom curve into equidistant points, and we can do that by getting the divide curve component and plugging that curve in. And we started with this one over here, but let's start with one of the easier ones. Let's start with the flat surface. So let's put the flat surface in. And just by the way, the reason that these are orange is because there's nothing coming out. There are no interior curves on the flat surface. And so don't worry about that. It's just a warning, just telling you that for one reason or another, nothing's coming out. Anyway, let's go back over here. And so by default, this count is 10. And so it's dividing this curve into 10 different segments. And what it's giving you are a list of points. And the points are the discontinuities or the endpoints, essentially, of all of those segments. And since there are 10 segments, and since this curve does not wrap back around on itself, there's going to be one more point than there are segments, and so we're going to get 11 points coming out here. So I don't need to see this for now. What's important is these points. We're going to use these to make our squares for the surface. And again, this is going to be very simple for the flat surface and for the circle surface. All I need to do is get a polyline component and plug these points into the polyline. And so this is going to give me a polyline with these segments made up of all these different segments. And so it's one curve or one polyline made up of 10 different segments. And let's go over to the circle and see what it looks like on the circle. You can see that it's going from point 0 to 1 and so on around the circle. And so now we have what will be the bottom of our squares, and you can see that it doesn't connect back here, but we want it to connect here for all of the closed surfaces. So for all the surfaces that come back and meet themselves, we do want this to connect. But for these ones, like the flat surface, we do not want this last point to connect back to this first point. So let's plug in this one again. And we can see again, on the polyline component, there's this closed input at the bottom, and this is a Boolean. You can see that little symbol, the hexagon, that's a Boolean symbol, telling you that it's taking a Boolean input, a true or false input. And we already made a Boolean, we already have a Boolean component here called wrap. So let's grab this and wire display hidden. So let's pull this up here. And right now this says true because this is wrapping. That's true. But when we plug in the flat surface, this Boolean is going to say false. And so that's exactly what we need for this closed polyline thing. We want it to be false if the surface doesn't wrap back around, but we want it to be true if the surface does wrap around. So we can plug that in there. And it doesn't wrap here, but if we go back to the circle, we can see that now this is closed. And so we have 10 different segments made by 10 different points. So what if we don't want necessarily 10? We want to be able to adjust how many segments there are. Let's get a number slider between, let's say, 4 and 50. And because I didn't type any decimals, this is going to be an integer. So let's also get an integer component. And we'll call this divisions. And because I'm going to want to bring this over to the left later, I'm going to copy this and make this a hidden wire. Copy that and call this number slider divisions. So one thing we should keep in mind, if we go back to this, we know that we want to create an alternating pattern. And so what that means, for all of the surfaces that connect back on themselves, we need there to be an even number of divisions, because if there are, say, 5 divisions, then this square and this square are going to have the same pattern on them, and we want the pattern to always alternate no matter what. And so this division number needs to be even. And so to do that, right click and say slider type and even numbers. So now no matter what, we're going to have an even number of divisions. And that's exactly what we want for the cases that this wraps around, but it's actually not what we want for the cases that this doesn't wrap around. So if we go back to the flat surface, in this case we actually want an odd number. And the reason for that is we're going to be applying a pattern in alternating fashion. So 0, 1, 0, 1, 0, 1. And if this is even, let's reduce this to a smaller number so it's easier to count. Let's say we have 4. We're going to have 0, 1, 0, 1. And then it's going to go back over here. And for the next level, it's going to say 0 again. So 0, 1, 0, 1, then 0. We actually want that to alternate back to 1. So we need an alternating pattern both in the horizontal direction and in the vertical direction. So we need 0, 1, 0, 1, 0, and then 1. So we have 0, 1, and so on going in the vertical direction. So what that means is if this does not wrap, we actually want this divisions to be odd. So we can do that just by getting an addition component and getting a panel. I just typed 2 slashes and then 1. That's going to give me a panel with the value of 1. So we're going to add 1 to the divisions for every time it alternates. And so if we have 4 here, it's actually going to output 5. So how do we make it so that every time we have a wrapped one, we have even, but every time we don't have a wrapped surface, we have an odd number? So we can get a component called stream filter. And stream gate and stream filter, these are good ways to kind of vary the pathway of whatever you're working with. It allows you to assess the context and, depending on what's happened before, change the pathway of the inputs. And so what we need is stream filter. And the 2 different inputs that we're going to choose between are odd. Well, actually, let's put odd in 0 and even in 1. So this is asking for stream 0 and stream 1, 2 different things that can go into this component, but only one is going to come out. And that's going to be determined by a Boolean. And guess where the Boolean is going to come from? It's going to come from this wrap again. So let's copy this component and we'll put it a little bit further back over here. So when wrap is true, we did this backwards. So the odd is going to go into 0 and the even is going to go into 1. So when the wrap is true, it will output a 1. So Boolean can be understood in terms of true or false, but it can also be understood in terms of like 1 or 0. And so let's get an integer and plug this Boolean into the integer and then see what's coming out. And I'm going to copy this and also plug in the Boolean output. And so you can see that when we plug wrap into an integer, it's going to Grasshopper will automatically convert it into an integer. And that integer is always going to be either 0 or 1. 0 is going to be equal to false. And then if we plugged in a circle, then the Boolean is true. And the equivalent to true is 1. So it's either 1 or 0. 1 equals true. 0 equals false. And so what this input is asking for is either a 1 or a 0, and that's referring to this 0 and this 1 here. If we had more filters coming in, then a Boolean wouldn't work for this. We would need an actual integer number coming in, but since we only have 2 outputs, a 0 and 1 is fine, or a Boolean going in here is fine because we only need 0 and 1. In the case where this doesn't wrap, it's 0, and that's when wrap is false. And when it does wrap, we need even, and the even divisions will go into 1. So when this wrap says true, what's coming out of here is going to be an even number. So let's test that just to make sure. So wrap is true. We have an even number coming out because it's coming out of this one input. And if we change this to the flat surface, then wrap is false. And it's an odd number coming out because we're adding 1 to the even divisions. So we have 5 instead of 4. Okay, if any of this is confusing, it should be. Nothing to worry about there. You'll definitely get the hang of it if you spend more time with it. But for now, since we have our outputs that's either going to be an odd number or an even number, we can plug this into our divisions. So let's get a default wire so we can see what's actually happening here. We don't need this integer anymore. So now this will be an even number or an odd number. In this case it's odd since this is not wrapped. And our polyline here has an odd number of segments and they're equidistant, which is what we want. But let's say we wanted to apply this to the triangle. Let's grab triangle. And let's decrease this a little bit to 4. So when we only have 4 segments, we can see pretty clearly that these are not equidistant. And why is that? So it looks like we're starting over here. We're going to this point, and this point, and this point. This divide curve component is dividing based on this length here. It has no idea what this angle is or anything about how this curve is changing. It only knows the length of the curve and where equal divisions would be. And so if you added this length here plus this length here, they would be the same. But since we need all straight edges for our squares, this length and this length is not going to be the same, and this length and this length is not going to be the same. But these two lengths will be the same since these are both straight. And the same thing will happen with our referenced curve. You can see that this length is much longer than this length because this is taking a turn here. So in the next video, we'll explore the difference between the straight curve, sounds like an oxymoron, and the circle curve, and all of the curves that we might be using. So why do the flat surface and the circle surface fall into one category while all others fall into another category? And that video is just going to be a quick tangent video. You don't need to watch it to follow along with this tutorial, so you can skip right to video 7 if you want. But if you want to explore curvature a little, video 6 is very short. So see you back soon, either at video 6 or video 7.